Now, another classic general chemistry calculation is determining the empirical formula for a compound. Now, this is actually derived or based as the name implies, empirical is experimentally derived or experimentally determined. So these are experimentally determined, where we might not know the exact ratio, but we could determine, or the exact number, but we could figure out the ratio per by mole of our compound. And so we can do this by doing a couple steps. So we're going to go through this, and these steps can pretty much be used all the time. So pretty straightforward, and so we'll do this for, so we'll write out an equation, or not equation, a problem. So iron and oxygen form a compound, so only two elements. That's important. And we're going to give you information about just the iron. So we're going to say, well, it's 72.36% iron, and that's by mass. Okay, now that's important. That's by mass. That's generally how you'll be given it. Because there's only two elements, iron and oxygen, you don't need to be given any information about oxygen, because you can determine this. So anything that's not iron is oxygen by mass. So it's asking to determine the empirical formula. So the first step is that a percent by mass is not super useful, and so what we can do is we can just assume that we have 100 grams of this iron and oxygen sample. So we assume that if we have 100 grams, that 72.36% of that 100 gram sample should be 72.36 grams. So that's a nice little trick. You can use, again, any mass you want, but 100 makes it easier because we're converting a percent. So we can write out the new grams of iron. And we can do the same for the mass of oxygen, because oxygen is the only thing that comprises the compound. Then we know that if you're not iron, you're oxygen, so we can just subtract 72.36 from 100, get 27.64, again assuming 100 grams, converting the percent to grams of oxygen. So that's the first step, converting percent from mass to grams. The second step is now we're going to want to take each of these grams and go from mass to moles. So we'll start off with iron. We're going to start off with the grams of iron, and we're going to look at the periodic table and find that the molar mass of iron is equal to 55.85 grams of iron per 1 mole. That's going to give us moles of iron on top, cancel out grams of iron, and that's 1.26 moles of iron. We'll do the same for the oxygen. So taking our grams, and we know that oxygen is 16.00 grams per 1 mole. And we find that we have, we're showing canceling. Man, it feels good to cancel out those units. So we have 1.728 moles of oxygen. So we can see a little bit more oxygen than iron. Now, once we have the moles, we can write out the formula for this iron oxide compound. Now we're going to put iron before oxygen because this is an ionic compound. Iron's a metal, oxygen's a nonmetal, and we always put the positive ion first, which in this case, and in all cases, is the metal, especially in a metal oxide. So we need to figure out what these values are. So we're just going to put in moles, the exact value for moles that we've calculated. It's good to keep this to a couple decimals places past the decimal, and you'll see why in a sec. Now, we need to make these whole numbers, and so what I'm going to do is I'm going to divide both moles by the smallest number, which is 1.296. So if you divide by the smallest moles, then that number becomes 1 for iron, and it'll become something that is bigger than 1 for oxygen. So that becomes 1. Oxygen, we actually have to calculate that out. And we find that if we calculate out, so iron is 1, and oxygen is 1.333, and goes on forever. So you might recognize that 1.33333 is actually equal to 1 1/3, or we can rewrite 1 1/3 as 4/3. I can multiply the 1 by the 3 and add 1. 4/3. So if I find it's easiest to write out the fraction as 4/3, and then we can see that if I want a whole number ratio, I need to multiply by the denominator. So I'm going to multiply both coefficients by 3. That gives us iron 3, oxygen 4. And there you go. So you might be asking yourself, man, that sure is a lot of steps. I wish there was an easy way to remember all these steps. And you're right. But lucky for you, we have a jingle. That's right. So these are going to be the steps. So first step is percent to mass, mass to mole, divide by a small, multiply till whole. Yeah, I know, it's pretty catchy. That's how I remember it. So those are the 4 steps. That's how you figure out the empirical formula. Not too hard, but it is a good amount of steps just to kind of do. So you definitely want to run through that a couple times. So you'll notice here that we are just showing I'm going through the jingle, showing you the different steps, and that goes in that order. So there we go. Hope you enjoyed it.